Okay, welcome back students, those who watch this video, and this we are continuing from that last class of this chapter, electricity. And here we will do a problem related to Ohm's law and a problem related to this formula electrical resistance. There's a relation between length of conductor and the resistance, and then specific resistance rho. And first we'll do the problem related to this formula, that is formula of Ohm's law. And this problem related to Ohm's law are very simple. This will be the 3 questions related to Ohm's law, and these 3 questions I'll solve for you, and then the rest question I will give, then you try it by yourself. These questions are very simple, and these are the favorite question of MBOSE. Okay, now look this first question. A current of 0.2 ampere. This A stands for the unit of current, that is ampere. A current of 0.2. Okay. A current of 0.2 ampere flows through a conductor of resistance 4.5 ohm. This ohm is the unit of electrical resistance. This symbol is the unit of electrical resistance. Then calculate the potential difference. Then we need to find the potential difference or the electric potential at the ends of the conductor. Okay, you need to know the symbol of what is the symbol of current and what's the symbol of resistance and what's the symbol of potential difference or electric potential. And here this I will stand for current, electric current, and V stand for electric potential or potential difference. Then R will be taken as electrical resistance. Then here in this question, number 1, this first question solution. Okay, first in physics, maybe the question in physics sometimes maybe you don't know how to solve it, and please follow this step. Whenever the problem on physics they give, always write first what is given in the question. And once you know what is given in question, then you can think which formula I can use here, because without knowing first what is given in the question, it's very difficult which formula I'll use here. This is not only for you class 10 student, even for class 12, for class 11. Always follow the same process. Always write first what is given in the question and try to figure out which formula I need to use. I need to find it here. Okay, like this question, a current. Then you already know what's the symbol of current. The symbol of current will be I. Then I'll write here given, because this is given from the question. Current. What is given? A current of 0.2 ampere. This will be the value of current, 0.2 ampere. Then next, what do you give? This current is flows through a conductor. This current is flows on a conductor of resistance. I mean, this conductor having a resistance of how much? 4.5 ohm. Then what's the symbol for resistance? The symbol for resistance will be R. Okay, I'll write here in bracket. This will be the current. Then here R, this resistance is 4.5 ohm. Then right here 4.5 ohm. This will be the resistance. Okay, only 2 is given. And then what they ask, calculate the potential difference. Okay, potential difference V. This will be equation potential difference. Okay, now here look, by getting this data I and R and V, potential difference, resistance, currents, then now you can figure out which formula you have to use. Then you go and check here and look which formula I have to use. Look, we need to find V, and I is already given, R also is already given. Then we look from here, then V is here, then I is there, and R is there. Then this formula I will have to use, or you can use this one, you use this one. But here in this question is direct formula is this one. Then you can write like this. We know, or you can write according to Ohm's law. We know, or you can write like this, according to Ohm's law, or you can write we know. What's the formula? Electric potential is equal to current into electrical resistance. Then you already have the value of I. What's the value of I? Will be 0.2. And right here 0.2. Then R is 4.5. Then you got how much? Look, when there is a decimal point, some students they are very confused to multiply. Please do not confuse it. Okay, look, when there is a point here, you don't need to scare about that decimal point. Just multiply the number. Now here is 2 and here is 4.5. Then just multiply 2 into 45. Look like this, 45 into 2. Then you got here 90. These are very simple for you, right? 45 into 2 you get 90. But when you saw this decimal point, it's very scary for you. Then now you got here how much? 90. But the exact answer is not 90. Look here. Now this 0.2 I can write here 2 by 10. This 0.2 I can write 2 by 10 because we will remove this decimal point. Then here 4.5 also you got here 45 divided by 10. Then some students, if they remove this decimal point, they will cancel this and this. Or no problem, you cancel. So 2 into 1, then 2 into 5, then 5 into 9. If you cancel like this also no problem, you get the answer. Okay, if you do like this or you do like this, we'll get the answer. Okay, now 0.2 I can write 2 by 10. Then 4.5 I can write 45 by 10. Now if you multiply, or if you don't multiply, you cancel it also no problem. Now 2 into 45 we got how much? 90. Then 10 into 10 we got 100. Then this 0 and this 0 will cancel. Now again left only 9 by 10. Then this 9 by 10 we will do the division. 9 divided by 10, how much is the answer? The answer will be 0.9. Now this will be the potential difference. And what is the unit? Please don't forget to write the unit of whatever quantity they give you. Current, the unit is ampere. Resistance unit is ohm. And voltage or electric potential, the unit will be volt. V-O-L-T. Volt. Please don't forget this unit. And then this will be, look, it is very easy or is very tough. The questions are very simple. It is given directly to the formula. Okay, now let's look to question number 2. this question now? Very simple. Okay, now I told you from the beginning that once we start every types of problem in physics, always write what is given and then we'll use which formula. Okay, now here the resistance of conductor of length, they given the length of this conductor. What is how much? 75 centimeter. Okay, then I'll write here. Because here, look, read the question. Resistance of conductor of length 75 centimeter is 3.25 ohm. In the resistance of this conductor is 3.5 ohm and the length is 75 centimeter. Then calculate the length of a similar conductor. Here there are two conductors, first conductor and the second conductor, but both they are similar to each other. If they are similar means resistivity will be the same. Then that's why we just write this formula: R by R2 is equal to L by L2. Here in this question there are two conductors. Then let's write first here given. Let's take the first conductor length of the first conductor L1. Length of first conductor is L1, that will be 75 centimeter. Then resistance of that first conductor will be R1. I'll take here R1 is equal to 3.25 centimeter, 3.25 ohm, not centimeter. Okay, that will be the parameter of first conductor. Length of first conductor, resistance of first conductor. Okay, let's look the second part. Calculate the length of a similar conductor. Mean length. Let's take a second conductor, but we need to find length. Calculate the length of similar conductor, means similar to this first one. The length mean this conductor and this conductor are similar to each other. Then what was the resistance of this? Resistance will be 16.25. Then here will be R2 is equal to 16.25 ohm. Then look here, what we need to find? L, and they given two resistance and one length of conductor, and the second one is not given. Then that will use this formula. Then I'll write here, we need to find R. We need to find L2. Okay, then write like this. I will interchange this formula somehow. Then I'll write this L2 up, this L1 down, and write this L2 then L1 equal to. Then if L2 and L1 are interchanged, then this R1 and R2 also interchange. Then R2 I'll write up, then R2 and R1. If we'll find L1, then I'll write first L1 here, L1 by L2. Then R1 by R2. Then if we find R2 also, I'll write first is R2 from this side, then R1 from this side. That will be very simple for you. Then now we need to find L2. Then this L1 I'll take it that side because here is a division. Then if we take this division that side, will change to multiply. Then I'll write like this: L2 is equal to R2 by R1 into L1. Now we'll substitute the value. Now what's the value of R2? R2 will be 16.25. Then I'll put here 16.25. Then R1 will be 3.25. Then L1 here will be 75. Then now we'll do the cancellation and then multiply, then we get the answer. Okay, now here two number after decimal point, and here also two number after decimal point. Both numerator and denominator have same number after decimal point. Then here 2, then here also 2. If we remove this decimal from here, we got 100. And if we remove this decimal point from here also, we got 100. Then from both numerator and denominator, we got 100 and 100 and 100 cancel. Then we don't need to write that one anymore. Then I'll just remove this decimal point directly. 1625 by 325. Because here from this 16 there is a decimal point. We got like this 100. Remove this decimal point. Then here also remove decimal point. We got 100 and 100 and 100 cancel. Then no need to write that one. Then I'll write directly like this only: 1625 by 325. Now we'll do the cancellation. Now can we cancel here? Okay. Now 5 into 6 will be 30. Then 5 into 25 will be how much? 25. Then here 5 into 3 will be 15. But here is 16. Then what left here? 1. Then that will be 12. Then 5 into 2 will be 10. then 5 into 5 will be 25. Okay, then it's better to do like this. And now this 3 to 5, and here also this 3 to 5. Okay, 6 to 5, then 3 to 5. It's better we'll do like this. Now 3 to 5. Now 3 to 5, if I multiply with 5, how much we got? Now 5 into 5, 25. Then 5 into 2 will be 20, 5 into 2 will be 10, 10 plus 2 will be 12. Then 5 into 3 will be 15, then 16. Then 3 to 5 into 1, then 3 to 5 into 5 will be 1625. Then now left only 5 into 75. Then multiply 5 into 75. Then 75 into 5, then 5 into 5 will be 25, then 5 into 7 will be 37. Then we got here 375 centimeter. Therefore, the length of the second conductor will be 375 centimeter. Then this will be the length of the first conductor 75, and length of second conductor will be 375. Okay, now we finish this question. We already got the length of conductor, and please don't forget to write length of conductor. Don't just write what we write just now, L2 is equal to 375 centimeter. Please write length of the second conductor is equal to 375 centimeter. Okay, then now we'll do this second question. Okay, second question will be related to this formula. Okay, what we need to find here? Okay, read the question. A cylinder of material is 10 centimeter long. Okay, the given that cylinder, the length of that cylinder, long mean length of that cylinder is 10 centimeter and has a cross section. This cross section means we're talking about the area or the size of that cylinder. The size of that cylinder is 2 centimeters square. Mean this is that size, this part. Okay, if its resistance along the length B 20, and they give the resistance also, and we need to find resistivity. Resistivity means this symbol rho here, this one. This will be called as resistivity. Okay, right first what is given. Okay, given length L is equal to 10 centimeter, and please remember, when we solve any problem, always we'll try to convert in SI unit. Then this centimeter is not the SI, because the SI unit will be here, will be meter. Then here we have to convert to meter. Then centimeter into meter we have to divide by 100, because 1 meter is equal to 100 centimeter. Please remember this one. Then in place of this 10 centimeter, I'll write here 10 divided by 100. Then we got here, how much we got here? 0 cancel. We got here 1 by 10 meter. Or this 1 by 10, I can write this 0.1 meter. Okay, then now next what is given, and has a cross section of 2 centimeter square. Then the given cross section means area will be the size of the conductor. And here also they give area is equal to 2 centimeter square. And here this centimeter also, I told you it's not the SI unit, we have to convert to meter. And remember this, to convert this I'll write here like this, 10 to the power 2 into 10 to the power minus 4 meter. I'll write here, remember this one, since 1 meter square is equal to 1 into 10 to the power 4 centimeter square. Because here we convert from centimeter to meter, that's why we got here minus. Then here also this 1 meter is equal to 100 meter. Then I convert from centimeter to meter, that's why I do division here, divide. This conversion, when we'll do mathematics in chapter 13, there will be so many conversion. I'll teach you there how to convert. Okay, then here length and A also given, cross section. Then what else they give? Resistance also they give. Resistance R is equal to how much? 20 ohm. And I put here 20 ohm, and we need to find what will be its resistivity. Then that will be rho. This will be resistivity. Resistivity. This we need to find. Okay, we know what's the formula. We need to find resistivity. Resistivity will be rho is equal to R into A by L. Then I'll write that formula. Rho is equal to R into A by L. Now what's the value of R? R is 20. Then what's the value of A? A will be 2 into 10 to the power minus 4. 2 into 10 to the power minus 4. Then divided by L. L here is 0.1 or 1 by 10. Okay, I'll take here 1 by 10. Or 0.1, no problem. Okay, I'll take 0.1. 0.1. Now 2 into 20 will be 40. Then into 10 to the power minus 4. Now this decimal, remove it, then we got here 10. Because if we take this decimal point, we got here 10. Then here we got, now here also 1 0 and here also 1 0. Then I can do that is 4 into 10 to the power minus 4 into, now here 1 0, here 1 0, I can write 10 to the power 2. Here 1 0, here 1 0, then become 2 zeros. Then here will be minus 4 and here will be plus 4. Then we got here 4 into 10 to the power minus 2. Because minus 4 and here is plus 2, we got here minus 2. Then what is the resistivity of this material? The resistivity of this material will be 4 into 10 to the power minus 2. What is the unit? Remember, please don't forget to write the SI unit. The SI unit of this will be ohm meter. Please don't forget this. The SI unit of electrical resistivity will be ohm meter. Okay, now we just finished that question related to this formula to find this rho, and this second question also related to this formula. Okay, I'll explain how to solve this question, then we'll come to this, then I'll write the question for you to try by yourself. Okay, now this question, a wire is 1 meter long. Again, same, they given the length of that wire is, length of the wire is 1 meter. 1 meter long, and here is, it's already given in meter, then we don't need to convert to any other unit. They already given in SI. Like in last question they give centimeter, that's why we need to convert it to meter. Then here, and 0.2 mm, millimeter. Now here this is not a meter, then again this millimeter we have to convert to meter. Now the given diameter D is equal to 0.2 mm. Now remember, this millimeter, mm means millimeter, is not the SI unit. Then here we have to convert it to meter. Then remember, to convert to meter, this one, you remember this one, 0.2 into 10 to the power minus 3 meter. I'll write for you all this conversion. Look like this. 1 centimeter, this will be 10 to the power minus 2 meter. Then 1 millimeter, this is equal to 10 to the power minus 3 meter. Then 1 centimeter square, this is equal to 10 to the power minus 4 meter square. Then 1 millimeter square, then this is equal to 10 to the power minus 6 meter square. Please remember this. This will be very important for you for doing conversion. Now in place of this millimeter, then I take this one, 10 to the power minus 3 meter, this one, 10 to the power minus 3 meter. And then what else they give here? Length they given, the size of the material they give, that wire has a resistance of 10 ohm. And they give resistance R, 10 ohm. And then calculate the resistivity. We need to find rho again, resistivity. Look here, check here in this question. I told you in physics always write what is given in the equation, then we'll check which formula we have to solve. Okay, now we need to find rho, then we already know rho, this is the formula. Rho is equal to R into A by L. Okay, R is there. Then L also is given, length. But area, A is not given, but they given instead diameter. Now this is the case, I told you in physics always check first what is given at that. Now from this diameter, can we find the area? This area, cross section, this circle part, this one. When we draw any conductor like this, now this will be that area of cross section, that circle part. And then, but they already given the diameter of that circle. in the diameter of that conductor or that wire. Then can we find the area? Yes. Remember this formula if you do know. Then we know area formulas. You have learned this formula. Area of a circle is equal to pi r square. You have learned this. Area of circle is pi r square. But there is also a formula like this. Same area of circle only, but that is in terms of diameter. That we don't need to convert this diameter to radius, because before you studied like this, that once I give diameter, always find first a radius, then you find the area. But here I'll give you a direct formula, area by using diameter. Then that I'll write like this: pi d square by 4. If they give you a diameter, to find the area, always write this one, pi d square by 4. But they'll teach you, if they give you diameter, find first the radius, then we'll find the area. Then that you do like this: d is equal to 2r. Then you'll find the value of r. But here we don't need that one. I will use this one, so that we don't need to use this. Okay, now area is equal to pi d square by 4. Pi d square by 4. Then here, pi, what's the value of pi? Pi will be 3.14. This is approximate value of pi. Then d, what's the value of d? This will be 0.2 into 10 to the power minus 3, because there is a square here, and I'll put also here a square, then divided by 4. Then 3.14 into, now 0.2 to the power 2, how much we got here? Okay, now 0.2 into 0.2, that's something right? 0.2, 0.2. Then here, if you are confused to multiply this one, then do like this: 2 into 2, how much we got? 4. 2 into 2, 4. Then here, how many point? 1 point here, 1 point here, and we got here 100. Got it? Then I'll do like this: in place of this 0.2 whole thing square, I'll write this one 4 by 100. 4 by 100. Now this 4, I'll put this one, I'll put it here. Look, 0.2 whole thing square means 0.2 into 0.2. Then 2 into 2, 4. How many point here? 1, 2. Because one number after point, one number after point. Mean there are two numbers. Then I'll got here 100. Then this one, 10 power minus 3, 3 power 2. Then this one, 2 into 3 will be, 2 into 3 will be how much? 6. Then here we got 4 and 4 cancel. Then we got 3.14 into 10 to the power minus 6. Now this 100, how many zeros here? 2 zeros. Now if I take these 2 zeros up, it will change like this: 10 to the power minus 2. Now minus 2 here and minus 6 here. How many zero here? 2. Then when we take this 2 zero up, it will change to 10 to the power minus 2. Then minus 2 and minus 6 will be minus 8. And we got here 3.14 into 10 to the power minus 8 meter square. Now we got the value of A. We got the value of A. Then we can find the value of rho. Okay. I'll write here. We already got the value of A. This is the value of A. Then thus electrical resistivity rho is equal to R into A by L. Then you substitute the value. What's the value of R? R will be 10. Then I'll put here 10. Then A, how much we got? A 3.14 into 10 to the power minus 8. That's the value of A we got from here. Then divided by L. L is how much? 1 meter. Then anything divided by 1. Anything divided by 1 will be equal to anything. Then here also anything divided by 1 will be equal to anything. But here now look, here how many 0? 1 0. And here will be minus 8 0. Then here will be minus 8 and plus 1 will be minus 7. Minus 8 and plus 1. Here minus 8 and plus 1 we got how much? Minus 7. Then here we got, therefore electrical resistivity rho is equal to 3.14 into 10 to the power, how much you got here? Minus 7. Then I told you don't forget to write the units. Then that unit will be right here. Unit will be ohm. ohm meter. Now we got the answer, and this will be the answer for this question. Look, in this question, what is not given? Area is not given. Given diameter. Then in that case, you need to find first the area. Then area is pi d square by 4. Okay. Then now we'll come to this next question. Okay. Let me rub first this one. Okay. Now I'll solve this question. Okay, a cylindrical conductor. This is a multiple choice question, MCQ. Let's say give the option here. Option A, B, C, or D will be the, which one will be the correct answer? Okay, now this question is from your textbook itself. Then this one, all that question which I did for you is all from your textbook. And then I'll give a question for you to solve also from your textbook only, because they won't give you from outside textbook, because due to this pandemic, maybe if they give also, they give a very simple question. Okay, a cylindrical conductor of length L. What's the length of this conductor? L. And a uniform area of cross section is A. They given the area, the size of conductor also, has a resistance R. Okay, I'll do like this. Case 1. Case 1, they given a cylindrical conductor of length L and a uniform area of cross section A has a resistance R. They given R is equal to rho L by A. And everything is given. Okay. And then another conductor. Okay, that will be, let me do like this, case 2. Another conductor of length 2L. Now we give what's the length? 2L. And resistance R. What resistance remain the same. And here write R is equal to rho, because this will be, look, of same material. Same material mean resistivity will be the same. Then rho, here also rho, here also rho. If they said same material mean the resistivity will be the same. The length will be 2L. Now in place of this length I'll write here what? 2L, because given was the length 2L, and has an area of cross section. What is the area of cross section? Now that we need to find. Okay, let me put that. Let me put this as A1, because this we don't know. Look here given has area of cross section option. Which one is the area? Okay. Now, but here both these two cases, this is a first case, then this will be the second case. But they said this also the resistance R, then here also the resistance R. Mean both they are equal. Then I will compare like this, comparing 1 and 2. Let me put this as 1. Let me put this as 2. Comparing 1 and 2. Then we got here rho L by A is equal to rho 2L by A1. Look, because both this also R, this also R, mean the resistance of this both conductor are the same. Then that's why I compare these two. Then comparing, then this and this has to be equal. But they said same material means resistivity will be the same. Rho value will be the same. Okay, then rho and rho will get cancelled. Then L and L will get cancelled. Now what left? Now let me take this A1 this side. Now, okay, I'll write first like this. Now left here 1 by A equal to 2 by A. Then I'll take this A1 this side, cross multiply. A1 into 1 we got here A1. Then A into 2 we got here 2A. Now what's the area of cross section of this new conductor? The area of cross section will be option number C. That is equal to 2A. Okay, this will be the question I'll solve for you. Then now I'll give the question which you need to try by yourself. Okay, I'll write the page number from your textbook. Okay, page number 132. This will be based on Ohm's law. Based on this formulas, solve this question. That will be practice problem 12. Now question number 1 I already finished to do, and question number 3. Question you need to do now. Question number 2, 4, then 5. This will be the question. Okay, then next in page number 126. Okay, now page number 126. Okay, this will be practice problem 2. That will be question number 2. Then this question is related to this formulas. Okay, now this question is, okay, I'll do like this. This will be Ohm's law, this one, then this will be this formulas. Okay, then now next question related to this formula, that will be, we'll go into page number 100. Okay, now page number 137 from your textbook, page number 137. That will be question number, this will be exercise 3b, question number 3. Okay, let me check maybe some more question related to this, then you can try it. Okay, this question will be related to this formula. Then last question, that will be page 139. Page 139. Then that will be question number 14.2. That will be question number 14.2. This question also will be applying the same formulas, but there will be some change here. Do check it. Remember, I told you for same material the resistivity does not change, whether if you increase the length of that conductor, whether you decrease the length of the conductor, whether you make that conductor big or small. This what is this one? This rho resistivity does not change. Remember, for a particular material, whatever you do for that particular material, the resistivity does not change. But if this is a one conductor, but this is another conductor, this is a copper example, this is aluminum example, then the resistivity will be different. But if this also is a copper, then this also is a copper, then remember the resistivity will be the same. Whether this is a big, whether this is small, resistivity will remain the same, does not change. Okay, then you do check that question, this page 139, question number 14.2. Then that question is related to that case for resistivity. We give two cases. Like this, I give the question, what is the change in resistance? Okay, resistance obviously will be changed. Once we already talked from in that factor affecting electrical resistance, because resistance is depends on length of conductor, and resistance also is depend on the area of cross section of the size conductor. If the length conductor is increased, then resistance also increase. Then if the size of conductor is increased, then resistance will be decreased. Mean resistance is changing as these two are changed, but resistivity does not change, does not depends on the length, does not depends on the area of cross section. Then do check the question, you try it. Then in next class or in next video, we'll do the problem related to that series circuit and parallel circuit. Mean the combination of resistor. Okay, then this will be the end of this video. Then please try to solve this question and send it to me. Thank you.